Okay, at the beginning of this video, I just want to finish up what I was doing in the last one, and that is to use the chain rule to find the derivative of number 9. So with the chain rule, I'm going to take the derivative of the outside. The outside function here is 2x squared. The inside function is 3x plus 1. So I'm going to bring down the exponent of 2, multiply that times 2, and I get 4. Leaving the inside alone, I get 3x plus 1. Then the derivative of 3x plus 1 is 3, and I multiply that out. Now when I'm trying to find the derivative at a particular point, I don't have to simplify this any further. I can just plug in x equals 1, something like that, and I get 3 times 1 is 3, plus 1 is 4, 4 times 4 is 16, and 16 times 3 is 48. Which gives me the same answer. So it might have been quicker to use the chain rule in this particular case, and you can use the chain rule wherever the chain rule applies, and either way I would have gotten the same answer. Let's go on to number 10. Alright, on number 10 I have a similar case. Well, here I have a product rule and a chain rule within the product rule. So kind of similar to the way we did this in class, I showed that the basic problem is a product rule. But within that product rule, I do have a chain rule for the first term, or for the first factor rather. And the inside function there is 2x plus 4, and the outside function would be x squared. So I'm going to have to use all that information when I go about finding my derivative here. So I start by saying that f prime of x, the basic structure is a product rule, so it's 1d2. And so that's just 2x plus 4 quantity squared times 1d2. So the derivative of tangent, you recall, is secant square of x. And that's 1d2, then plus 2, which is tangent of x. The second function is tangent of x. And the derivative of the first function, I could multiply that out, or I can use the chain rule. I'll use the chain rule here. And I'm going to bring down the 2 and multiply that times the quantity 2x plus 4. Then multiply that times the derivative of the inside, which is just 2. So it's bring down the 2 times 2x plus 4 times 2, because 2 is the derivative of the inside function, 2x plus 4. And I could simplify that out, or I could just start plugging in x equals 0 and see what I get. So for the first term, 2 times 0 is 0, plus 4 is 4. 4 squared is 16. Now I want to find out what secant of 0 is. To remember that secant is really 1 over cosine of x, so secant of 0 is really 1 over cosine of 0. Cosine of 0 is 1, and 1 over 1 is 1. And so we get secant of 0 is 1, and 1 squared will still be 1. So the first term is going to be just 16. Now I need the tangent of 0. And in case you forgot, tangent of 0 is really sine of 0 over cosine of 0. Sine of 0 is 0, cosine of 0 is 1. And so 0 over 1 is equal to 0. And so because that's 0, that 0 times anything will give you 0, and really you're done. That whole other side doesn't have to be evaluated, because when we multiply it times 0, it's 0, and our final answer then is 16. Okay, so that's 16. Number 11. So the derivative of that expression is 1/2 x to the negative 1/2 minus negative 3/2 times negative 3. When we bring down the negative 3/2, multiply it by negative 3, and then we reduce the negative 3/2 by 1, and it becomes negative 5/2. Well, 1 to any power is still 1, and so we get 1/2 times 1 plus 9/2, which is negative 3/2 times negative 3 times 1. You end up with 10/2, which is 5. And so that is number 11. And we'll continue this in the next, we'll continue with number 12 in the next video.